Hello, so today we are doing this problem called container with most water, and the problem says we get an array of integers such that each represents a point coordinates that are by I, the index, and AI. So the I is the index in the array, is the x coordinate, and AI, the value in the array, is the y coordinates. So you can see here for the first red one, the I coordinate is, since it's the second element in the array, it's 1, and then that's the x coordinate, and then the y coordinate, which is AI, is the value 8, and so that's the y coordinate. And we have n vertical lines, which corresponds basically to these endpoints. From I0 to IAI. So I0 is the one at the bottom, which is the start of the of this bar here, and we want to find two lines of these such that together with the x-axis, the one like parallel with the x-axis, they form the container that contains most water. And so you can see in this example here, the one that contains most water is the one colored blue here. And so that's this example, and the area of that one is 49. So how can we solve this problem? Let's take a look. Okay, so let's see how can we solve this problem. So the first thing, let's just look at the example that the problem gave us here, which was this one with 1, 8, 6, 2, 5, 4, 8, 3, 7, right? And so the indices here are 0, 1, 2, 3, 4, 5, 6, 7, 8, right? So let's just draw these out. And so what we had is the values here go up until 8. So let's just take 1, 2, 3, 4, 5, 6, 7, and 8. Okay, so after that, let's just draw these up. So we have the first one goes up until 1, the second one goes all the way up until 8, the one after that goes all the way to 6, and then we have 2, and then 5, 4, 8, and then 3, and then 7. Cool. So how can we solve this problem? So what we want is the container with most water. So the first thing we can do in this kind of problem, when we don't know what to start with, we can just start first and try a brute force solution. So what would a brute force solution in this case mean? Well, we can just examine all the intervals, right? And then count what are we interested in here. First, we want the container with most water. Let's just analyze that first a little bit, and then we can know how can we approach our brute force, right? So we want container with most water. So essentially, if we had a container between, let's say, this one and this one, it would be something like this, right? And then what is this this section here? That's just the area of what's in between, right? So essentially what we are looking for is an area, right? And so what defines an area basically? It's the width multiplied by the height, right? So in our case, for two heights, and what is the width and what is the height? So the width is just basically if we have indexes, so here the indexes we have are 0, 1, 2, 3, 4, 5, 6, 7, 8. the same as the one above there. So the width here of this area here is just this, right? So it's just 8 minus 6, right? And so the width is just the, let's call the last index j, but let's call this one a, and so the width is just j minus I, right? And then the height, what is the height? So the height is limited by the smaller one, because if you, the bigger one, you can't put water here because there is nothing to hold it on this side, right? And so the height is just the min of the two sides, right? And since we said I and j, this one is array of j and this one is array of I, right? So it's just the min of array I and array j. Or in the problem they call it heights. The array they call it heights. So let's just match that so we don't get confused later. So it's heights and heights here, and same thing, min of heights and heights. Okay, so now we know what the area is, and so now we can think about a brute force solution to this. So the brute force solution that we can do is just go through all intervals and compute the area between each pair. Using the formula that we just said, and take the max, right? So that's very simple solution, right? This will probably get a time limit exceeded, but let's just do it, and then from there we can take a look at what we can improve. So what would a brute force solution look like? So we said we are just going to go through the intervals, and then we go through the intervals, and from there we are going to calculate the area and pick the max, right? So we need the max area, something to call the max area, so let's call that max area equal to 0, and then we are going to go through every pair of intervals, and so that means going through length of let's call this heights. And with every other interval, so I plus 1, length of heights, and then we're just going to pick the max, right? So max area is going to become the max of max area, and then what is the area that we just saw that to compute the area we need the min of the height multiplied by the width, which is j minus I. And so that would mean we need to multiply by the width, which is j minus I, and the height, which is just the min of the value of the two, right? So the min of the heights of j and or I and heights of j, right? And so that will give us the max, and then at the end we can just return that, right? So very brute force solution. Okay, so that looks good. Submit. So you can see we got a time limit exceeded, and it passed on a good number of cases, but naturally, since it's brute force, we got time limit exceeded. Now let's see how we can solve this problem, improve it a little bit so that we can get it to pass. Okay, so how can we improve this solution? So one insight is that since we know what the area depends on, right? We know that it depends on the width and the height, right? So how can we maximize our chances to get the max area, right? So since it depends on the width, let's just pick the max width possible. So the max width possible is just to go through the entire thing, to just take the entire section, right? And so we can just take this entire section as a start. So but that means just put our I here and our j here. This will maximize our width, right? And then from there, take the max area of that. And now, how can we know how to move these two? So we have two options. We can either move this one, or move this one, or move both at the same time. So basically, let's look at the area in this case where it's as wide as possible, right? So the area in that case is something like this. Goes from here all the way to here. Why is that? Because of this smallest one, we can't go here, so it's useless that the height of this one is really big, right? And so to maximize our chances to get a bigger one, we need another taller one that is taller than this one, so that it can increase the height a little bit, because we can't increase the width, we have to go in advance, and that will only decrease the width because we have to go in one step further, and then if we go one step further, the width would be -1, would be the old width -1. And if we move this one, j, it would be still old width -1. If we move both, it will be old width -2. And so it's in our interest to maximize the width. And so to do that, we need to move one of the pointers, and now both at the same time. So now we rolled out the moving both pointers at the same time. And so now we know we have to move one of these pointers, which one we have to choose. So if we move this one here, if we move this one, so we can, if we move j first, if we move j, which means the one with the highest, with the largest height, that means that so the width became smaller, right? But the height, even if it's bigger than the one that we just have, we will still be limited by this smaller one, right? And if it's smaller, then it will be smaller than this one, and so the height would be also smaller, and so we'd have a smaller area. And so height will only be smaller, will only be same or smaller. So no matter what we do, is if we move the larger one, we will have a smaller area, right? And so that's not optimal. And so naturally there's only I left, right? And so if we move the I, which is the smaller height, right? We still know that the width will be smaller. The width will become smaller because we subtracted one. But the height, it will either be bigger, right? It will either be bigger, and in that case, it's either bigger than the height of j. So in that case, we are winning because the height will become the height of j, which means we will have a bigger area, or it's even smaller. But in that case, again, we will lose. But there is a chance that we will find a better area if the new one is bigger, which is the case with this one. So potentially here we might find a bigger height. Right? And so this one we are sure we won't find a better max area, but this one we might. And so might find a better area. And so it makes sense to move this one, right? And you can notice this argument that I just outlined here, it doesn't matter if it's for the left one or the right one, the same argument applies. And so that means that in all cases we will take the one with the smaller height and move that index. And if this one is the smaller height, we move that index, so we would need to make it to subtract one from that index, right? And so how can we code that up? So the code for that would be just something like So the pseudocode for that will be something similar to, let's take, so we will need 2 pointers. I'm going to call them left and right. That would be easier. Those are usually the names that we give to 2 pointers that are on one on the far left and the other starts on the far right. So we're going to have these 2 pointers, and one of them is the length of height minus 1 because it's on the far right. And then we're just going to go until they meet, because once they meet, we are done. We examined all the areas that we need to examine. And so you can notice here that, okay, so now we are going to go while they haven't crossed each other. If we are going to just apply this now, if the height of the left side is less or equal to the height of the right side, or less than the height of the right side, then at that point we are just going to advance L, because that's the smaller one, which is what we said here, always advance the smaller one. Else, which means the height of L is the one that is smaller, in that case we need to advance, we need to move the R index, which means just doing -1. So that would be -1. And then here we will update max area. So let's just call this update max area. Update max area, which would be the same thing we did with the brute force solution earlier. Just compute the new area using this new height and width and see if it's better. And so that's pretty much the pseudocode solution for this. And you can see we are doing one while loop and advancing each time 1 step. And so this one is O of n, such that n is the length of height. So it's a lot better than the brute force solution, which considered every pair and was O of n squared. And so hopefully this one will pass. Okay, so let's see the code for this solution. Okay, so let's code the better solution. So this solution, we said we need to have 2 pointers, so just the same as the pseudocode outline. And we need the max area that we will keep computing like we did with the brute force solution. And then while the 2 pointers haven't crossed each other, we are going to determine the height, which is just the minimum of the 2. So that would mean, and the same way as the brute force, and multiply that by the width, which is R minus L, and then from there see if this gives us a better max area. And so that would mean, oh, actually, sorry, I need to do that at the end, right? So this is the height, and that's max area. This is basically the part where we update the max area. And it would be the width multiplied by the height. You can just take this, put it here, return max area at the end, and here we can just do what I just did in the pseudocode, which is whichever one is smaller is the one that we need to advance. And so if this is smaller than height at R, we need to advance the smaller one, which is in this case L, and the left side to advance it we do +1. Otherwise it's the right side that is smaller, and in that case we need to advance the right pointer by subtracting 1. And that's pretty much all that is to it. And the solution is O of n. And so let's just run it. Let's call this height. Okay, this looks good. Let's submit. There is a slight issue with 1.1. Yep, so basically the problem is I didn't initialize with the I didn't initialize the first max area because I update right away and didn't initialize the first one. So let's just initialize max area to the first left and right, which is the far left and the far right. So the case where the far left and the far right form the max area, that wasn't computed. So we need to do that. Before assignment, yep. So this is just initialize it to this. Okay, so looks good. Okay, so this solution passes, and yeah, so that's the better solution than the brute force using the same calculation, but just cleverly traversing so that we don't end up doing O squared and using 2 pointers technique instead. Yeah, so that's it for the solution. Thanks for watching.